Hello everyone. In today's video, we are going to cover Chapter 12, Section 4, Volumes of Prisms and Cylinders. After studying this section, you'll be able to find the volumes of right rectangular prisms, find the volumes of other prisms, find the volumes of cylinders, and use the area of a prism's or a cylinder's cross-section to find the solid's volume. So, a volume of a right rectangular prism. The measure of the space enclosed by a solid is called the solid's volume. In a way, volume is to solids what area is to plane figures. So, volume of a solid is the number of cubic units of space contained by the solid. A cubic unit is the volume of a cube with edges 1 unit long. A cube is a right rectangular prism with congruent edges, so all of its faces are squares. In section 12.1, we use the word box for a right prism. Thus, a right rectangular prism can also be called a rectangular box. So the rectangular box above contains 48 cubic units. The formula that follows is not only a way of counting cubic units rapidly, but also works with fractional dimensions. So the volume of a right rectangular prism is equal to the product of its length, its width, and its height. So volume of a rectangular box is LWH, where L is the length, W is the width, and H is the height. Now, another way to think of the volume of a rectangular prism is to imagine the prism to be a stack of congruent rectangular sheets of paper. The area of each sheet is length times width, or the base, and the height of the stack is h. Since the base of the prism is one of the congruent sheets, there is a second formula for volume of a rectangular box. Again, length times width is the base, so the volume of a right rectangular prism is equal to the product of the height and the area of the base. The volume of a rectangular box is B times H, where B is the area of the base and H is the height. Now, this will also work for all other prisms. So the formula in Theorem 115 can be used to compute the volume of any prism, since any prism can be viewed as a stack of sheets the same shape and size as the base. So the volume of any prism is equal to the product of the height and the area of the base. So volume of a prism is equal to BH, where B is the area of the base and H is the height. Notice that the height of a right prism is equivalent to the measure of a lateral edge. Now, the volume of a cylinder, again, we can use the stacking property of sheets and apply it to a cylinder. So the stacking property applies to a cylinder as well as to a prism. So the formula for a prism's volume can be also used to find a cylinder's. Furthermore, since the base of a cylinder is a circle, there is a second, more popular formula. So the volume of a cylinder is equal to the product of the height and the area of the base. So volume of a cylinder is B times H. Remember, the base of a cylinder is a circle. Area of a circle is pi r squared, so I can use pi r squared h. Again, B stands for base, h is my height, and r is the radius of the base. Now, I can have a cross section of a prism or a cylinder. So when we visualize a prism or a cylinder as a stack of sheets, all the sheets are congruent, so the area of any of them can be substituted for the base. Each of the sheets between the bases is an example of a cross section. So a cross section is the intersection of a solid with a plane. In this book, unless otherwise noted, all references to cross sections will be to cross sections parallel to the base. We can now combine theorems 116 and 117 using the symbol C with a slash through it to represent the area of a cross section parallel to the base. Because again, the cross section is the same area as the base. So the volume of a prism or a cylinder is equal to the product of the figure's cross-sectional area and its height. So volume of a prism or cylinder is equal to the cross-section H, where C is the area of the cross-section and H is the height. Now, using these formulas in some sample problems, I want to find the volume of a rectangular prism. So I have this rectangular prism with dimensions 20, 5, and 15. Again, volume of a rectangular prism is L times W times H. Plugging in my length, my width, and my height, I would have 20 times 5 times 15, which would give me a total volume of 1,500 units cubed. Looking at problem 3, find the volume of a cylinder with radius of 3 and a height of 12. Again, volume of a cylinder would be equal to the base times the height. Notice in my cylinder, my base is a circle. So B would become pi r squared times my height. Plugging in my radius of 3 and my height of 12, I would have 3 squared, which is 9. 9 times pi times my height of 12. 9 pi times 12 is 108 pi. So the volume of this cylinder would be 108 pi units cubed. Problem 4. Find the volume of the right prism shown. Take the left face as a representative cross-section. So for this problem, I can solve it in 2 different ways. Like the problem suggests, I could take this face and make it a cross-section, then multiply the cross-section by the height, and that would give me the volume. Or I could split this figure into 2 rectangular prisms, find the area of both of those, then add them together. I'm going to take the area of the cross section and multiply it by the height because I find that to be a little bit easier. So looking at this cross section, if I label my dimensions, I'd have a dimension of 5 and 2 and 7 and 4. So the area of this up here is 10 and the area of my big space is 28. So the total area of this is 38 units squared. Now, if I remember my volume formula with cross-section, I have cross-section times my height. So 38 times 10 would be equal to 380 units cubed. So the volume of this right prism shown is 380 units cubed. In this lesson, we learned to find the volume of a prism or a cylinder, multiply the area of the base by the height of the figure. That's a wrap on this video. We'll see you in the next one.